Open the carton first. Remove the device package. Open the buckle on the side of the device soft bag. Unzip it. You can see it. Body of the device. Product manual. Warranty card and packing list. 2 adapters. Alcohol wipe. Charger. Data cable. A G45 network cable. Test remote. Line patrol. First, press and hold the power button to turn it on. We can see several major functions in the main interface. On the right is our express entrance. By pressing up and down, you can see the second page function of the shortcut entrance. Let's explain the OTDR function below. Enter the OTDR interface. We can first see the top is the OTDR image display. On the right is our test button, file button, save button and time map. Time list, not a time map, time list. Below the image are our basic parameter settings. The wavelength, pulse width and test mode. Choose. Test mode we can choose automatic mode, implementation model and average model. The choice of range and the choice of measurement time. Advanced settings also includes test settings, analysis settings, and disk distance settings, save settings, and restore the default number parameter. And here's a quick demo. So the first thing we do is we plug the fiber into the device. First open the dust cover of the OTDR interface, connecting fiber optics. Here we can choose the automatic mode to start the test. Wait for the test to end. We can see the OTDR image of the test above. Below is a list of events. The ones shown in the event list are ours. The starting position and the end of the ray. Top left corner of OTDR image shows our measurement mode. We have chosen this time 2. Dynamic mode and measurement parameters. Contains a wavelength at 1310 nanometers. Range 40 kilometers. Bandwidth 3000 nanoseconds. The distance between the cursors is shown on the right, loss and average loss. Through this result, we can learn that the length of this fiber is 14.8521 kilometers. We can click the Save button. Save the image. The data is saved. If we want to call a number, when you want to call up the saved data, click File to bring up our saved file. The following explains the stable light source function. The following explanation. The following explains the stable light source function. Enter the stable light source. We can see interface for stable light source displayed on the interface. Also for our OTDR interface. After we connect the fiber optic to the equipment, you can see the switch. Click Open, click Open. We are now turning on the V1550 nano laser stabilized light source. Click on the wavelength to switch between different wavelengths. The device is available at 1310 nanometers and 1550 nanometers. Click Mode can switch between different frequencies. Here our device can choose the CW mode, 270 Hz mode, 330 Hz mode and 1000 Hz mode, 2 kHz mode. Now, let's introduce VFL red light function. We can see interface for red light function. For our second interface on the right, open the dust cover. Remove the dust cap. Connect fiber optic devices. So we're going to give you a little demonstration here. After connecting, we can see red light functions by passing light at 650 nanometers. It goes into the fibers to visually determine the red band of the fiber and the location of the loss point. You can see the button on the right click. Open. You can see it. If there is a red band in the fiber, or the loss point can be intuitive. See the red light in the fiber optic cable. Leak situation. To determine the fiber optic cable, red band and loss point location, click 1 Hz. We can get a red light that flashes once per second. 2 Hz can get red light flashing twice per second. Click to close. Let's introduce the function of optical power meter. The optical power meter function is to use the first interface. Open the dust cover. Remove the dust cap. The main interface of the interface is real-time optical power. Real-time optical power. The upper left corner shows our test wavelength. By clicking the wavelength button, you can switch between different wavelengths. Here, our device measures 1310 nanometers, 1550 nm, 1490 nm, 1625 nm, 1650 nm. You can click the reference button to set the reference value. After setting the reference, we can get the reference power. Below us are the reference power, linear power, and the frequency of the light source. Calibration button. The calibration button can be passed through the stable light source. Calibrate the optical power meter function of the device. Let's introduce the event map function. The event map function is to convert OTDR images of OTDR feedback to us intuitively and graphically. So let's start with the event map. You can see divided into our right side is the test start button, world map function, save button, file function. Here we simply test. We'll start by plugging fiber optics into our devices. OTDR interface. Click directly to start the test. The test can choose from 150 nanometers. 1310 nanometers can also choose two at the same time. When two options are selected at the same time, measurements will be made using 1310 nanometers and 150 nanometers, respectively. And the results obtained twice are summarized. The measurement is over and wait for the measurement to end. After the measurement is completed, we can see a visual graphic display at the top. Graphical display. The position of 0 represents the start of the device. The dot 1 is the end of the fiber. In the middle is the time list. In the time list, the position 0 represents the start of the device. Device location. The starting position represents the end of the fiber. Below are 1550 nanometers and 1310 nanometers. Measurement parameters twice. And the final result of the aggregate. We can save the result by clicking Save. You can also click the file to open the one we saved before. Result. Below us. Below. Now we will test the long-term continuation of our J45 lines. Continued, and below we test the RJ45 network port. Function explanation. Entering, we see that the interface is a line sequence measurement. When measuring the line sequence, we can look at the line sequence measurement. We can see that on the right is the test start button, including toggle T568B line sequence. So let me just give you a quick demo. Follow the network cable as shown. Connect to our network cable interface in the lower left corner. The other end of the network cable is connected to our RJ45 network cable. Far end. Click Test. Wait for the test to end. We can see that the result is an HY pass-through. Let's introduce the line inspection function. Line inspection function. You can see the line patrol function. At this time, the live test with wire is supported. The buttons on the right are Start, Stop, and Sequence switching. Switch back to line sequence measurement mode and exit. We connect the network cable to the designated RJ45 network cable interface. Click to start. We need to take out our patrols and load the batteries. Now press and hold the switch on the line finder. The power indicator is on. When the line finder is close to the network we are connected to, line time, the line finder will beep, and the indicator light is on and flashing. At this moment, this proves that the network cable is the network cable we are connected to. Let's introduce the file management function. File management function. We can see where different folders can be selected. You can see different files in the folder. For the file, we can open it with multiple selections. Rename and delete operations. Optical loss test, optical loss test. Optical loss test function. We need to put the jumper first. Connect to our OTDR interface. Interface with OPM. Test according to the prompts. After the test is completed, we then connect the component under test into this optical path. Run a second test. 2 tests will determine our test. The loss of the device in this optical path. System settings. We can see that the first item is information about the system. Contains basic information about our equipment. The second item is the software update function. Compass. Software updates can be performed through this function. Power saving settings where we can see automatic shutdown time and screen time and screen brightness settings. Tip tone settings, there are touch tone settings, respectively. Key bump tone settings and power on sound. Click on the next page. It also includes connection settings. Connection settings include USB connection settings. After the USB connection settings are turned on, we can plug the USB stick into our USB port. Plug it into the USB port. Data is carried out through a USB stick. Copy. Below is our Bluetooth connection line. By scanning the QR code. Device connection. Time and date are set by addition or subtraction. Language settings. You can switch between different languages through the language settings. Factory reset. This feature will clear all user information and setting parameters. Please use with caution.